So this is where I left you at the end of the last example. We're about to move on to the next page, page 8, but here's, I'd asked you to factor 2x squared plus 9x. Well, the only thing that's common between the two that I see is an x. To very quickly check that, I can simply write out 2x squared not equals 2x squared will factor prime factorization 2 times x times x. 9x will factor 3 times x. The only commonality I see is x. So x is a factor. What am I left with up here? 2x. What am I left with here? 9. It would be 2x plus 9. And again, that's using greatest common factor, which is what we tend to focus on when we are doing most of our factoring work through the rest of this chapter. Okay? So factoring using greatest common factor. Find the greatest common factor of each term. Write the polynomial as a product of the greatest common factor and the rest of the expression. So we can work this through with 2 terms, 3 terms, 4 terms, as many terms as possible, and as big as those terms happen to be. So we just have to make sure that we follow it step by step and not lose track of any of our little extra bits of our terms. So for factoring using greatest common factor, we take each of our terms, in this case 5. What's going on here? Take 5, which is just going to be 5. We take our 10z, which is going to be 2 times 5 times z. And we take our 5z squared, which is 5 times z times z. There's our factors, or there's our prime factorization of each of those terms. What's common between them all? Well, I see a 5 common between all of them and nothing else. Okay. So 5 is going to be one of my factors, and I'm going to multiply that by with all of the stuff that's left over. Now this is where you have to be careful. Down here, 5z squared, what's left over? Z squared. 10z, if I take out a 5, I'm left with 2z. Oh, that's an ugly 2. 2z. Here, I'm left with nothing, but I can't have nothing. The idea of factoring is that you're dividing. So if I'm dividing or factoring out a 5 from a 5, well, 5 divided by 5 is 1. So this is a big common mistake, place for errors, making sure that if you do factor a term by that exact same term, in this case 5, that it doesn't become 0. It's a 1. There's always a 1 there. So make sure that you remember that. So then I just write this out, 1. And in this case it was, what was the sign here? Minus, oh, I don't need that, that's ugly. Minus 2z minus z squared. And there's my polynomial all factored out. What you could do with algebra tiles, except that there's lots of algebra tiles here, what you could do with this in algebra tiles, get all of the tiles that you need, make your set, and then you want to arrange that set into a rectangle, or if you can, into groups. So then you would arrange that into a rectangle. Far too many algebra tiles to be playing with, especially if I have to draw them all out. Hence one of the drawbacks from actually using algebra tiles with bigger polynomials. Okay? So that's example 1. Example 2, when we return.